HTTP? So HTTP stands for Hypertext Transfer Protocol. Today it's used to access web applications on the World Wide Web. So it is the underlying protocol that helps us to retrieve web applications. HTTP is basically a client-server protocol, and it has a message-based model to carry traffic between the server and the client. So the client requests a resource on the server, and the server runs a response message to the client. HTTP 1.0 was the first release, which, well, it's considered obsolete today, but it's still possible to see if you're testing an application on an intranet, so bear that in mind. HTTP 1.1 has replaced the older version, and it's the most common version that's out there used today. Persistent connections, option method, and improvement in caching mechanisms are just a few of the better features of 1.1. Now, as the internet evolves, HTTP is extended and leveraged with new features. Even new releases come out to support today's more complex applications. So the latest version was published in May 2015 as HTTP 2. Now, HTTP 2 has many great features. Basically, this new release removes the performance-based issues for web applications, and it's also supported by modern web browsers and updated servers. All right, so after this new version pops up, I need to update some of my rhetorical sentences about HTTP. Normally, it's a text-based protocol, but now it's a binary protocol with HTTP 2. Now, it is an application layer protocol in the TCP/IP model. Now, as you know, HTTP is a stateless application level protocol where the server and client exchange and process data. So it uses stateful TCP as a transport mechanism, although HTTP itself is a stateless protocol. But with HTTP 2, they can use the same TCP connection. And by the way, it uses the default port 80 on the server, unless the web server and the client are configured to use a different port. Now, I want to flag that up for you as a pen tester, because an application can be served on another port. So first, let's talk about the HTTP request and responses. An HTTP request is made by the web browser, and HTTP responses are sent by the server. So let's have a look at the HTTP request message. Request messages are comprised of two parts: the message headers and the message body. Headers provide both the server and the client instructions on how to handle the message. So the structure of a request looks like this. First, the mandatory line comes, and this line consists of an HTTP method, the path or URL of the resource, and the supported HTTP version. Then request headers come, and then headers are followed by a mandatory blank line. And finally, the message body is added to the request. And that is the real HTTP request data. Then this request is sent to the server. Okay, so now let's have a look at the structure of an HTTP response. The structure of a response message is similar to a request message. Again, the mandatory first line. Now this time it consists of the HTTP version, HTTP status code, and phrase. Then the HTTP response headers come. And then the headers are followed by a mandatory blank line. And then finally the message body comes. And that's the HTTP response data, just like that. And then this response is sent to the client. Now, sometimes if there is no data to be sent between each party, the message body can be neglected. So now let's have a look at how to examine these messages from the browser. So HTTP messages contain useful data to gather information about applications or also to manipulate applications. So what we need to do is capture whole HTTP traffic sources between us and the web server to extract the information. Now, there are several ways to capture the traffic, and the most common way is to use a local HTTP proxy. I'll show you that in detail in the next video. But for now, I am going to observe right here in my browser HTTP traffic with the developer tool. So developer tools are very useful to analyze the application in the web browser. So first, I just open the web developer tool. And there are several tabs within this internal tool. And HTTP messages are listed and viewed under the Network tab. Then go to the Vulnerable Applications Login page. So as you see here, HTTP requests are listed below. And also it can list documents by their types. I'll only list HTML documents now. Now I'm going to click on the first request to see the details. And over here, the right pane of the tool, there are details about the request, such as HTTP headers, cookies, parameters, and so on. Now this view may be different in other browsers. And now the tool displays data about the request and response in its own particular way. Okay, so normally there are 3 items in the first line of every HTTP request, separated by spaces. But developer tools show the request not quite like this. So this is not the raw data, but you can get the raw data as well. So the first part contains the URL, HTTP method, and version information. Now, an HTTP method defines how to use a source on the server or what to do with it. Now, as I said before, the client should inform the server about the action that it wants to perform on the requested resource, right? So a web browser can display, delete, or update a resource by declaring an HTTP method in the request. Now, because there are several HTTP methods, they all work differently. But mostly what you'll see is get and post methods. Get is, I would say, the most used one. And what it does is it helps to display a resource on the server. Get requests do not have a message body, so you cannot send data in the message body. But it doesn't mean that you cannot send data with the get method, because get can transmit any parameter to the requested resource in the URL with a query string. So this is a practical way to send data. But a parameter like that becomes part of the URL, and that means it's prone to sniffing. And as a web pen tester, you should try to force the application while transmitting confidential data, whether it uses get or not. The post method is similar to the get method, and it's used to retrieve data from the server. So now I'm going to log into the application. As you see, the data is sent via the post method, and choose the post request from the list. And the post method has the message body, and it mostly transmits the data to the server in this way. Now, click the Params tab. Here's the login data that I entered, but the get method transmits data via query string in the URL. So choose the HTML injection example from the list in the page, and fill in the input fields with some data, and hit enter. Click the request, and now look at the data in the URL. Then open the Params tab, and this time it is identified as a query string. So it is entirely and absolutely vital to use the post method while transmitting confidential data. You get me? Now, in addition to the get and the post methods, there are a few others: put, delete, head, and options. The put and delete methods are part of WebDAV, which is an extension of the HTTP protocol. Put creates a new resource or replaces the target resource using the content contained in the body of the request. So as pen testers, we may be able to upload a malicious file to the server if this method is enabled. And the delete method deletes data on the server, as the name would suggest. So these are called dangerous methods, and you might be able to guess why. So in other words, you should analyze the application for these available HTTP methods. So to check the available methods on a server, another HTTP method can be used. The options query, which is an HTTP method on the server. So click Edit and Send. Now I'm going to change the method to options and delete this part, then send. And the server returns a response and declares an allow header, which stores the available methods. And let's have a look at the available methods. Here they are. So head is another method, and it checks whether a resource is present on the server or not. And it works the same way as the get method. So this time, I'm going to change the method to head and send the request. And here's the basic header information for this application. So it's a quick way to get some information from the server. And HTTP supports many headers. Some of the headers that can be used for both requests and responses, and others are specific to one of these message types. So why don't we start with some of the request headers? The host header specifies the host name in the URL. It can also be an IP. The point here is that it is absolutely necessary if there are other web applications on the same server that share the same IP address. User agent specifies the information about the client software. Then if the request is generated by the web browser, it is going to contain browser information. See why that would be useful. Cookie submits cookies to the server that the server previously issued. So cookies can be used for many reasons by the servers, software, or developers. And we're going to come back to cookies a little bit later on in details, but we need to learn a few more things first. So referrer is used to indicate the address of the previous web page which the client requests the current page from. Also, this header was misspelled in the original HTTP specification, and it's still used like that. Accept encoding defines the compression scheme supported by the client. gzip and deflate are among the most common ones. So accept tells the server about the content types that the client can accept, such as image types, Office document formats, and so on. Connection tells the other party to close the TCP connection if the HTTP transmission has completed, or keep it open for further messages. Content encoding tells the other party about the encoding used for the content of the message body, such as gzip. Okay, great. So now let's have a look at the response message. So here is a status code, which represents the result of the request. Okay, so it's a numeric value, and it's followed by a textual reason phrase, the OK message. So each HTTP response message must contain a status code. There are 5 groups of status codes. Status codes that start with 1 is informational. Status codes that start with 2 define a success message. Status codes starting with 3 are used for redirection. Status codes starting with 4 define errors caused by the client. Status codes that start with 5 define errors caused by the server. For example, 200, 302, 404, 500, those are some of the more popular ones. So 200 OK indicates that the request was successful and that the response body contains the result of the request. And then when I log out, I'll get a 302. And the 302 found redirects the browser temporarily to a different URL, which is specified in the location header. Now, if I request a non-existent resource, I will get a 404. 404 not found indicates that the requested resource does not exist. Okay, so some response headers. So the server header provides information about the server software used in the server computer. And sometimes some other details such as installed modules and the server operating system can be included as well, not mandatory. But you're looking at it here. So Pragma directs the browser not to cache the response. Expires tells the browser for how long the content of the response is valid. And the browser caches the content until that time. Content type identifies a type of content in the message body, such as text or HTML for HTML documents. Content length specifies the length of the message body in bytes. Cache control passes caching directives to the browser. So in this response message, there is no set cookie header. Set cookie submits to the client additional parameters named cookies. Now, cookies can be used for any reasons, but typically they're used for authorization. Now, we're going to recap cookies in the next section in full detail. Now, as you know, HTTP is a stateless application level protocol where the server and client exchange and process data. So it uses stateful TCP as a transport mechanism, although HTTP itself is a stateless protocol.